Couche, everybody. Welcome to our third video update. We are Team SPAZ and we're working on the Njala Illinois Care Unit, or NICU. This video update, we will be talking to you about what we've done in the past 2 weeks, some of the things that we plan on doing in the next couple of weeks, and we'll be showing you demos of each of the components of our devices and how we have started integrating them together and constructing them for our device. Alright, so I'm going to do a quick demo of some of the experiments that we've been running with the phase change material. So what I have here is, I believe this is 66 to 34% lactic acid to palmitic acid. The darkish gray color is from the 10% aluminum powder that's in there. This is a sample that we've already run. There's a close-up. But basically what we do is we heat it down so it's melted. We mix it up and then we put it in the styrofoam cooler. Actually behind me, if you see behind me, Sarah's running an experiment right now on one of the other samples that we're doing. But I just drop it in the styrofoam. This one's obviously got a larger hole cut in the lid. And then we put the thermometer in there and we take temperature readings every minute. And our goal is to keep it in the target temperature range of about 35 to 37, 38 degrees Celsius. And so currently we are finishing up with running some of the test samples. We're deciding, based on the info that we found from the first with the calorimetry experiments, we're using that as well as this aluminum powder data that we've already collected to try to find the best mixture in terms of percentage of both acids and then in terms of percentage of aluminum.
Okay, so Zach just talked about the PCM experiments that we're doing, and so the next step is going to be actually making a mattress that is going to be filled with that phase change material. We've ordered some materials. We ordered some Mylar in order to help retain the heat a bit better, but we've been waiting on that for the last 5-ish weeks, so hopefully this should be coming in soon. It's been ordered and stuff, so just kind of sitting here waiting for that. We also ordered PTFE, which is a variety of Teflon. But as you can see, it's really thin, and the website was actually wrong about the thickness, and it told us it was 10 times thicker than it actually is. So that's kind of a bummer, but we've also been looking into other materials to use for the mattress. So we've taken a look at some water beds, hospital beds, and actual other incubators that have similar types of mattresses that are heated, and we've been looking at purchasing some materials for that. So our plan is, before the meeting and after this video is filmed, we're going to have those materials ordered. And once we have those, we're going to test different combinations, so different thicknesses of the mattress, and then measuring the surface temperature of that as we change different dimensions. We're going to then combine that with the temperature sensor that Sarah and Ashley have been working on and make sure that we can sense the temperature of the mattress as it's cooling and heating the baby, ideally.
So for the last 2 weeks, Ashley and I have been working on the temperature sensor, and we've been working with Dr. Poole to help create this. The main thing that we're working on currently is creating a calibration curve, and so we just want to do that several times in order to make sure that it's as close to what's actually happening as possible. So we're pretty much done with our first one. We need to create 2 more just to kind of see how things average out, but this is how we set it up. So what you see here is this is our temperature sensor. It's a thermistor, and it's coated so that it's waterproof and things like that, but we have it attached to 2 electrical leads just so that we have more mobility on it, and we have it electrically taped so that hopefully there's no exposed metal, and then that's what the styrofoam is for, so that when we actually take the temperature for our calibration curve, it's not exposing any electrical components in water. So it's then, currently the way we have it set up is we have it set up with a DAC and set up to lab view and an oscilloscope. And so basically what we would do is we hit run on lab view, we put the thermistor into the water, and then we make sure that we check the temperature. So then what we see on the lab view here is you'll have a plateau before the thermistor gets put in, then it goes up to the temperature of the water, or down depending on the relative temperature of the water to the air, and then we pull the thermistor out, and when we pull the thermistor out, it'll then equilibrate back to the air temperature, also seen in lab view, and it's the plateau that we take a look at and compare to the temperature written on the thermometer in order to create the calibration curve.
Upon testing our circuits, I noticed an issue that we were having where no matter how high the temperature was after it exceeded 45 degrees Celsius, the voltage always maxed out at 9.3 volts. So after talking about that with Dr. Poole, we realized that the resistance is going to have to be changed on part of the circuit, which could significantly change a lot of the voltages that we've already measured. So testing might have to begin again on those temperature sensors. So this is all the tubing that I have so far for bubble CPAP. I'm using the PEX connectors as T-junctions between the different sizes of tubes. The one size of tubing that I'd like to kind of continue using is 3/8 diameter, and it fits in really well with the T-junction that I have, but the T-junction doesn't fit in very well with the nasal cannula, and I really need those two pieces to connect. I tried looking around for another size of connector, but I couldn't really find any. So I'm trying to kind of make the one size of tubing a little bit bigger so it fits into the connector. This is a picture of the manometer that I made to test the water pressure for the bubble CPAP. It's just a simple tube that's mounted onto a board. I used some zip ties that came with some of the tubing I got and just kind of created a U shape. So one end will go into the water column and the other end of the tube I used to kind of fill with water. And so how I kind of tested the pressure is you just fill the water up until it gets to the 0 mark, and then putting the other end of the tube into the column makes the pressure go up or down depending on what it is. So I wanted to achieve 5 centimeters of water in the water column, so I just waited for one side of the water in the manometer to rise up to 2.5 centimeters. So doing this, I found that sticking the other end of the tube down to the 32.75 mil mark line in the conical tube achieved the 5 centimeters of water that I was looking for. I figured that filling the tube to that 50 mils and then using the 32.75 as a marker would be a good indicator of getting that pressure consistently with any size of tubing, even though I used a bigger size for establishing the pressure in the first place.
Last week we asked you, from which language does the name Sierra Leone originate? Nobody answered again, sad face. But the answer is Portuguese. The name of the country comes from Serra Leal, which means lion mountain range in Portuguese. This week, your task is to determine which singer used his music videos of diamonds from Sierra Leone to emphasize the suffering caused by conflict diamonds and the abuse of human rights that happens in the mining process. Comment with your answers below.